All right, so today we are doing the Ellipses Lab. All right, so ellipses. All right, planets do not travel in circles around the sun. Rather, they travel in a shape called an ellipse. Now, the difference between an ellipse and a circle is a circle has one center to it, all right? And as it goes around that center, anywhere on the circle, you're always the same distance away from that center. With an ellipse has two centers to it, and those centers, individually, each one's called a focus point. Together, they're called foci. And an ellipse has two of them, so it's going around those two foci. Now, when our Earth goes around the sun is located at one of those two foci. So sometimes we're closer to the sun and the sun looks bigger. Other times we're farther away from the sun and the sun looks smaller. All right. Now, this is an ellipse. This is also an ellipse. But just by looking at them, you can tell there's a difference between them. One of them's more circular, looks kind of more like a circle. The other one's flatter. So instead of just calling the shape an ellipse, to have a more precise description of the shape, we use a formula called eccentricity. So eccentricity formula is on the front page of your reference tables, right near where the density formula and the rate of change formula and stuff like that. It's on the very front page. So the formula for eccentricity is distance between foci divided by length of the major axis. So distance, or E is D divided by L. All right. So distance between foci, that's how far apart those 2 points are. Length of the major axis is from there all the way to there. All right. So let us figure out the eccentricity of these guys right there. And there it is. All right, so for this guy right here, distance between foci, I'm going to measure that in centimeters. And I find that out to be 3.5 centimeters. Length of major axis is all the way across like that. I measure that and I get about 13.7 centimeters. All right, so now I do my little math. 3.5 divided by 13.7, I get 0.255. Usually these things are rounded out to the thousandth. All right, so mine's 0.255. There's no unit on eccentricity because centimeters divided by centimeters cancel each other out. So it's just a number. There's no units on that. All right, that's a great number. What does it mean? Well, let's do this one here and see how it compares to this one here. All right. Distance between foci, between the two dots, I get about 10.5 centimeters. Length of major axis from there to there, I get about 19.3 centimeters. So 10.5 divided by 19.3 equals 0.544. So what you should notice then is when that number is lower, when the eccentricity is lower, it's more circular. When the eccentricity value is higher, it's flatter. Now the lowest value you could have for eccentricity is 0, all right? Because 0 is the eccentricity of a circle. So that is the lowest value you could have. The highest value you could have for eccentricity is 1. All right? Because 1 is what the eccentricity of a flat line would be. So your shape is always going to be somewhere between a circle and a flat line. So your value is always going to be somewhere between 0 and 1. So it's always going to be a decimal. If I ever do a calculation where you end up with an eccentricity of like 2.7, then I know I did something wrong. I probably divided backwards, because it's impossible to have an eccentricity greater than 1. Or if I had a negative number, I know I did something wrong as well. All right, so today's lab, what we're going to do is we're going to construct 3 ellipses. And how it's going to work is I'm going to construct them on the projector up here. And you're going to have to make your measurements off the projector. So you're going to need a ruler to make the measurements from your computer screen or from your tablet screen. All right. Now, if you're wondering to yourself, well, what if one person's going to do it on their iPhone, another person's going to do it on their tablet, another person may do it on their larger computer screen at home? Isn't that going to mess up the numbers? No, it doesn't, because it's actually a ratio. So your D and L's might be different, but your E's would still be the same. So it doesn't matter what size screen you use. You're still going to get the same value in the end. All right. All right, so ellipses. The shape of the school track is called an ellipse. The shape of the orbit of each planet in our solar system is also called an ellipse. Unlike a circle, which is a curved shape drawn around a single point, an ellipse is a curved shape that is drawn around 2 points. Each of these points is called a focus. Together they are called the foci of the ellipse. An ellipse is described as an eccentric because it is not shaped like a circle. The more unlike a circle an ellipse becomes, the more eccentric the ellipse is said to be. All right, so how you draw an ellipse is you put two tacks in a piece of cardboard, and then you take a string with the ends of it tied, you put a pencil, and then you pull this string tight and you draw it around like that. So that's what I'm going to do. Again, I'm going to do it on here on my desk, but it's going to be projected up here, and you're going to have to make your measurements from this. All right. All right, so we're going to do 3 ellipses. So ellipse 1, ellipse 2, and ellipse 3. All right, so there's one of my foci, and I'm going to measure over and put my other foci right there. So there's my 2 foci. So I know there's some shadowing there, so I'm going to darken in. So right here and right there. So there and there, those are my two foci. So you want to, this is ellipse number 1. You want to measure, again, using your ruler, and you're going to be measuring it on your computer screen. You want to measure the distance from there to there. That's your distance between foci for ellipse number 1. All right, now to actually draw the ellipse, I take my string, my pen, pull it tight like that. Now I draw my ellipse like that. So there is ellipse number 1. There's ellipse number 1. So for the length of the major axis, you want to measure the distance from there all the way across to there. So from there all the way across to there would be the length of the major axis for ellipse number 1. Distance between foci, length of the major axis. All right, so what I'm going to do next is I'm going to leave one of the tacks in place, and then I am going to move the other tack so the two tacks are farther apart. Okay. So I'm going to move this one. All right, so this is for ellipse number 2. For ellipse number 2, here's my one foci, here's the other foci. So distance between foci, you want to measure that distance right there. All right. Now I'm going to draw the ellipse for ellipse number 2. All right, so for the length of major axis, you're going to be, for ellipse number 2, length of major axis, you want to measure from there all the way across to there. All right. So ellipse number 2, length of major axis, you want to measure from there all the way across over there. All right. For ellipse number 2. All right, so ellipse number 2, distance between foci, you want to measure that, length of the major axis from there to there. All right, so then for ellipse number 3, I'm going to move this tack again farther out. So for ellipse number 3, distance between foci for ellipse number 3, you want to measure from there to there, that distance right there. And then for length of the major axis for ellipse number 3, you want to measure from there all the way across to right there. So from there, going across to right there. So ellipse number 3, distance between foci, length of the major axis. Okay. Now, to calculate the eccentricities, remember it's going to be the formula that we just went over. It's from your reference table. Eccentricity is distance between foci divided by length of the major axis. Also remember when you calculate your eccentricities that I want you to round it to nearest thousandth. And remember that there are no units on eccentricity because centimeters cancel each other out. Okay. Now, one last quick thing I want to show you about with the eccentricities. Is that there is a chart All right, in your reference tables is the solar system data chart. And we've looked at this chart before. So I had stuff like the planets and how far they are from the sun and their period of revolution, period of rotation. When I showed you this the first time, I just mentioned briefly that eccentricity at orbit told you the shape of the orbit. I said we'd come back to it on another day. Well, that's today. So eccentricity at orbit there, this tells you the shape of the orbit around the sun. Remember with this number right there, the closer that number is to 0, that means that the planet's orbit is closer to being a circle. The bigger that number it is, the more eccentric it is. That means it's less like a circle and flatter. But that's what that number right there means in your reference tables. All right, so to answer some of the questions for this lab, for like 3 of the questions, you have to use this chart right there. So once you have your eccentricities calculated, you have the questions to answer with it, and what you need to submit is a picture of your the data table you filled out and the answer to your questions. Make sure your name's on them, and then you can upload those to Schoology. And that's the Ellipse Lab.